So now this session is a continued session of the matrix multiplication. So in the previous video we have already seen how we can multiply two matrices and what is the necessary condition to check before starting this process. So there is one identity which we need to clarify whether the matrices follow that identity or no. So that identity was the commutative law. That was commutative law. So as in the case of linear algebra, I already told you that if you multiply any two numbers, it will give you the same result as the previous one. So if you multiply a by b, you will get the same result as you will multiply b by a. Means the order does not change, does not have any effect on the result or the product obtained. But this is not the case in the case of matrices. This is not followed in the case of matrices. So this thing we are going to check and see how the results are affected by changing the position of the matrices. So in the previous, if you refer to my previous video, I have taken two matrices in that. I am taking that same in this also. So I have taken two matrices M and N. M had components as 1, 2, 3 and 4, and second matrix was matrix N, which had elements 5, 6, 0 and 7. So we multiplied M and N and got the product as 5, 20, 15 and 46. Now we'll multiply n into m. Means your first matrix will be your n and your second matrix would be your n. So n had elements 5, 6, 0, 7 and m had 1, 2, 3, 4. Both the orders are 2 cross 2, 2 cross 2. We don't have to check the number of rows and columns because it's same. Okay, now when you will multiply these, let's see how the result is getting affected. So we'll start with row 1. This is your row 1, this is your row 2, this is your column 1 and this is your column 2. So first step would be you will traverse this row 1 through column 1. That means 5 will be multiplied by 1 plus 6 will be multiplied by 3. When whole first column is traversed, then you will move on to the second column. So we will write it as 5 into 1 plus 6 into 3. First row, first column done. Now first row of n matrix and second column of the m matrix. So now 5 again will be multiplied by 2 and 6 will be multiplied by 4. Now first row, the job of first row is done. Now you will move on to the second row. Now this second row will be multiplied by first column. So 0 into 1 plus 7 into 3. Then you will have 0 into 2 plus 7 into 4. What will be the addition of these components? This is 5 ones are 5 plus 6 threes are 18. So 18 plus 5 is 23. This would be 0 into 1, 0, 7 threes are 21. This is 5 twos are 10 and 6 fours are 24. 24 plus 10 is 34. And this is 0 into 2 is 0 and 7 fours are 28. So if you try to visualize, I'm using some different page now, your n cross m or n dot m, the resultant matrix was 23, 34, 21 and 28, and your m dot n was 5, 20, 15, 46. So if you can see, both the matrices are totally different, although the parent matrix was same. Means m and n, you're taking those same matrices, but if you're changing the order of the matrices, the product you will get totally different. The products will not be same. So m dot n is giving you this resultant, and n dot m is your this thing 23, 34, 21 and 28. That means commutative law is not followed, or commutative law cannot be followed in the case of matrices, since you are not getting the same product when multiplying the matrices. All right. So if you get any such questions where you have to justify, then you can simply rearrange the matrices in whichever order they are asking and check whether you are getting the same result or no. So if you have any problem, if you are stuck at any question, you can drop me in the comment section and we'll see how we can go through it. So stay tuned for the next upcoming topics. We'll go one by one. Thank you.